Hello, Benjamin from Eclipse here. We are back for another virtual IoT webinar session. And today we're going to talk about an Eclipse project called Eclipse Vorto. Vorto, I think, has been contributed sometime last year. And yeah, the development team is working quite hard on developing the features behind Vorto, and we've invited Olaf from Bosch Software Innovations to give us an overview about the current state of Vorto, what you can do with Vorto, how to get started, and yeah, I think there will be a few cool demos today. So as always, please make sure to ask questions while we do the presentations, as when the presentations we have enough time to actually answer them. So several ways to ask the questions. For you guys on Twitter, just make sure to tweet the questions using the virtual IoT hashtag. And otherwise, if you're watching us on Google+, you should be able to find a Q&A section. That's also a way for you to contact us. The comments on Meetup is yet another way. Anyways, I'll leave the mic to Olaf for the presentation, and yeah, I'm really looking forward to learn more about Vorto. Welcome, Olaf.
So thank you, Benjamin, very much for giving me the opportunity to present Vorto again. I'm working for Bosch Software Innovations, and I'm responsible for several standardization topics and for device abstraction topics. And so I'm also the project lead of Eclipse Vorto. My talk today is divided in two parts. So I would like to give you some information about Vorto itself, for what is Vorto good for, and so on. And afterwards, I want to show you what we are thinking about when we talk about Vorto as a service. So let me start with the first slide. And what you can see here are a few devices. And you know, Vorto is about device abstraction. So our main target is to create a tooling that makes it really easy to create device abstractions, device descriptions that perfectly describe the capabilities, properties, and so on from devices. So here you can see, for example, a camera, you can see a washing machine, some power tools, a car, and so on. And for every such device, you can create an information model. Vorto provides an IoT toolset, which makes it really easy to describe a device. I will also give you a live demo later. Of course, Vorto also provides a repository for managing and sharing such device descriptions, or we call it information models. And yeah, we also have a technical meta model that defines the grammar of our DSL, which is used for such device descriptions. And the meta model is based on Eclipse EMF, and within the repository, we are storing then XMIs. So one important point for Vorto is that we do not intend to create a new standard. We just want to provide a technical tooling that supports the process of describing devices, managing such device descriptions, and integrating devices into specific applications, into IoT platforms, whatever. So now, if we have a closer look at the camera information model here. The camera information model, of course, needs to contain some information about the functionalities of a camera. We do this using function blocks. A function block is a group of functionalities, properties, and maybe events that are related to a specific functionality, like a camera here. So we need a function block for a camera. Depending on the model of the camera, there are other function blocks there. So, for example, a location function block. Maybe the camera itself provides a functionality to check where it is located. And here in my example, I have a third function block, a motion detector function block, because it's possible that the camera maybe sends an event if a motion has been detected. But if we look now at this part, location, then we see, okay, a location is not only a useful thing for a camera. Of course, this is also useful for an information model, for a car information model. A car information model, for example, can describe an interface of a car that is provided for applications. So a very important point on Vorto's side is that we want to reuse as much as possible. So this is why we structuring all such functionalities in these function blocks. Function blocks are also managed and shared in the Vorto repository. So let's go to the information model of the car. And you can see this is just another example here. You can see the same function block location is used there. Of course, we have here other function blocks, configuration and running status and whatever, depends a little bit on the interface of the car. So how are these information models structured? You can see this here. An information model only groups these function blocks. Information model itself has no properties, it has no operations. There are only function blocks in there. The operations, properties, and so on are specified in the function blocks, and these function blocks can use data types. For example, for the properties, for example, they can use data types as a return value of an operation. They can use data types for the parameters of an operation. But if these function blocks are only using simple data types, you do not need such complex data types at all. Of course, these data types can reference each other, and there are also enums available here. So let me show how this looks like in the Vorto toolset. What you can see here is the Vorto toolset, which is realized as an Eclipse plugin. If we open the data type for location, then we can see here we have a namespace, we have a version, we have a display name, a description, and a name. Within the Vorto repository, every entity, every data type, every function block, and every information model is uniquely identified using the namespace, the version, and the name of the element. So in this case, we have that namespace here, org Eclipse Vorto example, version is 1.00, and the name is location. Here we have two properties in that entity. We have a latitude and a longitude for this location. Both attributes have the data type float. And here, in addition, we have specified a measurement unit. This is degree in this case. And here we have some constraints. And of course, we can add on property level descriptions. So here, just for an example, the position function block reuses this location data type and provides a property current position, which is of type location, which was that data type here. And but here is a small constraint. This one should only be readable, so writable is set to false. And here is an operation which returns the location. And now let's go to the information model. And this information model then uses that function block position. That is how you can model in Vorto. Here is an integration of the Vorto repository. So of course you can browse the Vorto repository and download and reuse already existing components. So you can see there are a lot of example models in there. Okay, let's go back to the slides. Here again, the example that I showed you in that short live demo. you can see, okay, on property level, you can add descriptions. On property level, you can define constraints. You can specify the measurement unit for every property, of course, the data type. You can specify a name for every property, and you can choose if this property shall be mandatory or optional. Now, maybe you will ask, okay, I have already chosen a standard for my device descriptions in my applications. Why should I use Vorto now? And yeah, there are several answers. Of course, Vorto is not really a new idea. So because there are a lot of standardization organizations, for example, that already work with device descriptions. They have created standards, and yeah, device description is something that is well known. But now, why should you use Vorto? The reason is that most of these standards that are already available do not really have a tooling. There is no tooling to really easily create the device descriptions, and there is no tooling for managing them and sharing them, making them public, and so on. So now Vorto, as I said, shall not be an additional standard. It shall be a useful tooling. And so if you already have chosen a standard, then it is possible to implement a so-called importer. That importer reads your device descriptions and maps them to the Vorto meta model. And then you have the possibility to store these models in the Vorto repo. And then you can share and manage them. You, of course, can also use the Vorto toolset that I already showed to edit them, to change them, to work with them. And in the end, you can use code generators to generate code out of them. So for example, if you have chosen maybe the SDT Smart Device template for creating your device descriptions, then you can import your descriptions. They will be mapped to the meta model. You can manage them in the repo. And now it is possible to maybe create a specific code generator for your applications and create the format that you need. But of course, it is possible to use existing code generators, a code generator like Java, which allows you to generate Pojo classes out of that description, or maybe a code generator that generates OSGI DAL representations. You can generate XML, you can generate documentation. These three are only examples here. And in the Vorto project itself, there are a lot of examples already available, what can be generated. I will also come back to this and demonstrate 2 use cases where Vorto is currently used. Okay, so now let's go to the Vorto repository. And the headline of the talk already said that we want to talk about Vorto as a service. So we saw the situation that it makes totally sense to provide more functionalities of the Vorto repository than we already did. So in the current version that we are hosting at Eclipse, you of course can search for models. You can filter for information models, function blocks, entity, and enums, and you can browse the contents. Of course, that makes totally sense, and that is a minimum functionality that you expect when you're talking about the repository. You can download the models, you can share models there, and so on. What we added in the new version so far are small things here. You can now sort also the contents, and you have a pagination. But we also added a an easy-to-use REST interface here. And this REST interface allows a lot of more functionalities than it did before, because, of course, you again can search models, download models, delete models if you have the corresponding privileges. You can upload images, and these points here are new. You can register and deregister code generators, and you can also generate code. And why did we integrate that code generator infrastructure into the Vorto repository? There are a few reasons. One reason is that when you have an application, let's say an application that has a protocol adapter, and this protocol adapter communicates with devices, then it might be that you connect a new device to that protocol adapter, but this device is not well known to the adapter or to your application. In this case, it might make sense to contact the Vorto repository, browse the repository, and download a specific model, which afterwards allows a communication with this device. So you have some kind of runtime scenario and not only a design time scenario. So that is one reason why we said, okay, it makes sense to integrate these functionalities into the Vorto repository. Another reason is that, let's say, if you are not a developer, you just want to create, I don't know, a documentation for a specific model that you found in the Vorto repository, or maybe that a colleague of you have shared or has shared there, then maybe you do not really have an Eclipse platform installed on your computer. So, but still you want to generate code, and now this is also possible using the web user interface, which I will show you later. So the new architecture of the Vorto repository now is the following. The Vorto repository is a Spring application providing its REST API, and it provides the functionalities where code generators can register. So the code generators now are microservices. They are also Spring Boot applications, and they are registering themselves and their functionalities on the repository. And afterwards, the repository provides the functionalities of the code generators to client applications and also via the user interface here. So in this way, it is possible to, for us on the Eclipse side, it's possible for us to host a few code generators there that register at the Vorto repository and provide their functionalities. But of course, it's also possible for companies to say, okay, I've implemented a code generator, I host it in my own environment, but I register this code generator on the public repository of Vorto, and then people can use it. Okay, now you will have the question, why should I do that? Why should I provide functionalities to the public repository, and why should I share my models in that public repository? There are also a few reasons why that makes sense. Because if you, for example, are a device manufacturer, then you are interested in making it easy for your customers to integrate devices into their applications or into the platforms. So if this is a very easy process, then in the end, it's easier to sell the devices. So in this case, it makes sense, okay? It makes sense to provide device descriptions in that public repository. But now you might say, yeah, but I do not want to make the USPs public. Maybe I do not want to provide all the functionalities of my device, but this is also possible. So you can create a device description with a subset of functionalities of the device and share this in the public repository. And maybe you have hosted the Vorto repository in your private, company private environment, and there is an information model containing all the information about the device. This is also a scenario. Okay, the other thing is, why should you provide a code generator and register it on that public repository? I think it's the same reason. That code generator exactly knows what is needed for integrating devices into your platform, because a code generator will always be platform specific. So you are providing a tool to the public that allows, or that makes it easy to integrate devices into your platform. So you're making it easy to integrate devices into your platform, so it's easier to use the platform. And these are the reasons why this would make sense. Now let's go to the repository web user interface, and what you can see here is the generators tab. After a code generator has registered itself on the Vorto repository, then you will find it in this generators tab, including a logo and a description about his functionalities. And what we also do is we provide here the most frequently used code generators. So you can identify these most frequently used generators, and you can browse everything that is available on the repository. Now, if you click on an information model, then you can see here on the right-hand side, there are also the platform generators, and you can execute them there. That means you can select an information model. Here I have my multi-sensor as an example. You can click on it, and then you can generate code for it. Here we have 3 examples: a Bosch M2M, a Web UI code generator, and a Java Bean. So that was this part, but there is another important part, and this is, we added a discussion tab here. Because when models are publicly available, then it makes totally sense to allow people to discuss about these models. Maybe specialists can discuss if the model is correct, if something could be improved, if something is missing, and so on. And that is also a new functionality that we have added here. Of course, on model level, you can find all relevant information about the model. So let's go to a second small live demo. This here is the repository as we currently host it internally. You can see we have added here a few example models. And here, if you click on it, then you find, of course, a preview of the model here. You can see here are a lot of function blocks in there. Here in this example, we have a humidity sensor, pressure sensor, light sensor, magnet switch, accelerometer, magnetometer, and so on. And the repository shows all these dependencies also here. So you can click on these dependencies and also view these models. And again, here you can see which model use them and the other references. So I can go back here, and I'm back in the information model. So now I can say, okay, I would like to have that model as a Java Bean. Then I can click on this here in the code generator, and now I can download the generated code. You can see I can download here a zip file, and this zip file then contains the generated classes. This is this part. Of course, when you go to the generators, you can see here the available generators, and you can go to the documentation and so on. But let's go back here to the discussion functionality. And you can see here there are 2 comments already there. My colleague said, okay, this model looks pretty good for him, and I agreed with him. And that's the way how it works. Of course, you can log in to the repository. So first, you need to sign up. then you can sign in. Then you can also share models in there. This is very easy. You can just upload models, and yeah, you can try this out and play around. I must say one thing. Currently, this new version of the repository is not hosted in our public environment, but we will do this in the next week. We are currently waiting for a few approvals, and after we have them, then we can commit the code to the repository, to the GitHub repository, and afterwards we will host this new version there. But as I said, a few CQs are currently missing. Okay, another thing that I wanted to show you is that it is possible now to subscribe to the repository here, and if something changes in the repository, then you get a notification here. And of course, you can play around with the REST API here, and this one here can try this out. For example, this controller. Here you can register, deregister the code generators. That is this functionality, and here you can browse for models and so on. Try out here everything then. Okay, this is the repository web UI, but as I said, it is also possible to access all the functionalities via this REST API. And another way how you can do this is this Vorto CLI tool. And that is also something that I would like to show you. We have implemented a CLI tool that helps to work with the Vorto repository via the command line. So you can say here, Vorto help, and then you see a lot of commands that are available for Vorto. So for example, I can say Vorto query, and I want to query all the contents of the repository, and then you can see, okay, there are a few models in there, namely 23, and now you can also get details for every model. So let me copy and paste this. Just insert this command here. I want to get more details to that data type temperature unit, and then you can see, okay, it is an enum containing temperature measurement units. You have a display name, you have the namespace, and so on. And it has been created by my colleague Alex, and it is used by another model, namely the temperature model here. Now, another thing that you can do is you can say, I want to download this model now, or I want to download an information model. And you can also include all the dependencies. So this is possible here. You can say Vorto download, then you say which namespace it is, and the name and the version, the unique identifier of the model. You can say, okay, I want to have this as an output, namely the DSL, and you specify a path. So for example, the current directory, and you can say include the dependencies. Then it downloads everything, including the dependencies. Now you see here, the download was successful. And if I look into my directory, then I can see here the my dir has been generated or created. So I can go in there, and you can see here is a zip file with the contents that I've downloaded. So, but there is another thing that I want to show you. You can also have a look what generators are available. So you can say Vorto generators. Then you see, okay, you have a few generators available in the repository. They have currently registered at the repository. And so you can also execute a generator and retrieve the content. So let me insert this one. I say Vorto generate, and I say, okay, please generate code for the TI sensor tag model here. And please generate for an MQTT client, and an output path has also been specified here. Then I say, okay, generate, takes a few seconds, and then we can have a look. And we can see here a TI sensor tag zip file containing the generated code. So yeah, it's a nice small tooling. It has been written in Go language, and yeah, it makes it really easy to work with the repository and to browse the repository to generate code and so on. Okay, but let's go back to the slides. So, because last but not least, I want to present a few use cases how Vorto can be used. And for example, we used Vorto in the IIC track and trace testbed. And this is an interesting thing, what we did there. On Processed side, Processed provides a gateway here, gateway stack for communicating with devices. Processed has a lot of protocol adapters where devices can be integrated. So for this showcase here, we integrated a Nexo NUT runner from Bosch Rexroth here into the Processed gateway. And we did it using a code generator. So, you know, on Processed gateway is mainly based on OSGI, and there are a few technologies how devices can be integrated into that gateway. In our case, so-called functional items are needed. So we created, using that code generators, functional items out of a NUT runner information model. Then a developer added a little bit of code, because this is only a code skeleton that we have generated in this initial version of the code generator. And afterwards, the gateway could communicate with the Nexo NUT runner. So afterwards, ThingWorx, on their side, they implemented a code generator that provides a model that included or showed the ThingWorx platform all the functionalities that are available, and it is also possible, using the generated artifact, to access the REST API of the Processed gateway or the Processed MPRM server, and so a communication could be established using Vorto between these two solutions. And now, because the Nexo NUT runner model had specific data types in there for the communication, and the same data types have been used here in that Processed integration, and in the ThingWorx integration, we had interoperability between these two solutions and between the device. And so the communication was possible, and you could see in the ThingWorx platform the data that was coming from the Nexo device. That was one interesting showcase. Another one is this one here. And this is something that is currently developed in the Bosch Corporate Research Division. And it's about communication within a car and communication between applications and a car. So within the car, devices can communicate using the SUM-IP protocol, and a Vorto code generator can create now clients and server side. So it enables a communication between a gateway in the car and a device in the car. Now, co-op is used for a communication between an application and the gateway within the car. So there are two things necessary. On one hand side, you need the code generator for creating that server and client implementations for SUM-IP and for co-op. On co-op side, we are using Californium. But there must also be a mapping between these two protocols, because when you expose functionalities from specific devices via co-op or via SUM-IP, then you need mapping to the co-op protocol to expose these functionalities to applications outside. And these mapping happen within the gateway there. And this is a showcase that a colleague of mine from corporate research has implemented And we will use the co-op code generator examples to for a tutorial that we will have at EclipseCon in Reston to describe the Vorto approach. So there will be more details about this specific scenario here.
Olaf, do you mind if I quickly interrupt you? We have a question on Twitter
Okay.
regarding the MQTT example.
Yeah.
I think you will need to maybe explain a bit more how an MQTT broker and Vorto can be integrated. Yeah, it's unclear whether what is exactly what you would generate, whether you would actually use MQTT to query the information models and stuff like that. So maybe you can quickly go back to that example. Thanks.
So what we did for on this side is this is part of also a part of a demonstrator, and this MQTT code generator creates a client that allows to retrieve data from a Mosquito server, and it also creates an implementation to push data to an MQTT to the Mosquito. So the following scenario was covered using that code generator. We had a device that communicates with Cura. The data were pushed using that generated artifact into the Mosquito, and the client, which was also generated using this MQTT code generator, then retrieved the data from MQTT and displayed them in a web UI, which has been generated using our web UI code generator. That was the scenario that we had there. And so we are not really pushing information models or so using MQTT. It was an IoT scenario for which we generated that code.
Okay, and is there in such a scenario, is there a need for the developer to actually write some custom code specific to the actual setup, the actual deployment that he or she is targeting, or are the code generators supposed to really take care of generating something that just works because everything is already in the information models?
It depends a little bit on the scenario. So what we can do here is we provide a code generator that generates an artifact for retrieving and pushing data to MQTT. So this artifact works out of the box, but you need to integrate it into your scenario. So if you say you have a sensor and maybe you have a gateway or so, then you can retrieve the data from the sensor, but then you need to transfer it into that code artifact, or then you can include this code artifact that has been generated into your solution and then use it. So the big advantage here is that the data that is pushed to MQTT is conformant to the data types that have been specified in Vorto. So when you push data there, you exactly know how the data are structured, and when you retrieve the data again using the client, then again you exactly know how the data is structured, how it looks like, and so on. Then you can directly use it, and you have some kind of semantic information there. But this code generator, of course, is very specific for the Mosquito use case.
Okay, thank you.
Okay. So yeah, let me go to my usual slide, putting it all together. This is the complete overview about the Vorto scenario, how it should work in the end. So I have three stakeholders here: the device manufacturer, the platform vendor, and the solution developer. A device manufacturer can use the IoT toolset to describe his devices, maybe including USPs, maybe without USPs. Then he can check the device description, the information model, into the Vorto repository, and now it is publicly available if he has checked it into the public repository. Otherwise, maybe it's publicly available within the company. And then a platform vendor, or maybe it can also be an application vendor, whatever, can create a specific code generator that transforms this information model into a format that he needs. For example, in our IIC testbed track and trace use case, we generated Java code for processed, very, very specific Java code, these so-called functional items. And on ThingWorks, there was something else generated. And but there are no restrictions. Whatever is needed can be generated here. For example, Java, C++, XML, XSB, JSON, whatever. And the solution developer in the end can use that generated artifact to integrate a device into the platform, the application, whatever. So this would be a perfect scenario. So of course, not in every situation you can generate all the code that is needed to integrate a device. So it depends a little bit on the application. It depends a little bit on the protocol. It depends on the complexity of the device. It really depends on a lot of factors. But there are scenarios where I would say you can generate all the code that is needed for an integration. In other scenarios, maybe you can create code skeletons that are needed, and the developer has to add a little bit of code. And as I said, it depends a little bit, but of course, Vorto can harmonize the device integrations. That's in every case possible, and it can reduce the efforts, and it enables interoperability, because the more entities, data types, and function blocks are reused, the more interoperability is enabled using that tool set. Okay, before I stop, I would like to show 4 talks that are also related. So one is a talk about how to allow smart devices to communicate using Eclipse Vorto. Here we are really showing in detail how our code generator generates Californium-based implementation for a co-op communication. Our code generator generates a client side and the server side, and so in the end a communication is possible. And this one is a tutorial at EclipseCon. In this talk, I want to give an overview about use cases that we already have for Vorto. I will not go in every detail, but I will give a good overview about this. My colleague Caio Dalla will talk a little bit about the IoT server platform and I think the related Hono project, which has been started now. And Michael Hirsch will talk a little bit about software provisioning and, of course, the Hawkbit project. Okay, so that was what I wanted to tell you today, and so thank you very much. Are there questions?
Let's see about questions. So yeah, I don't see questions right now on Twitter. Let me double check on the Google Plus event page. So I guess one thing that I would like to ask is what's on your roadmap? I mean, you've mentioned the repository, which is going to be improved quite a lot. The features you've demoed regarding integration with the generators and stuff. Are there plans regarding specific code generators that you would that you plan on including? Like I don't know, things related to maybe the DIY community and generators for Arduino or for Embed or things like that?
There are a lot of plans. Maybe 2 things that are the major things that I see on the roadmap for the next month. One is the meta model for Vorto, because we are getting more and more requirements for the meta model. So specific things cannot be modeled so far using our DSL. And so we will extend that and improve the DSL, improve the meta model to make it possible to really model devices from arbitrary domains. So in the end, we really want to be able to model devices from smart home, from automotive, from Industry 4.0, and so on. That is one main target that we have. We want to make it more useful, and again, it must be easy to model everything. So this is a lot of work to do to keep it easy, but to cover the complexity. And the other thing is Eclipse Vorto, the IoT connector, a new project that is started. I think Henry Konsek and Kai Hudalla are project leads there. This project is about connecting, let's say, protocol adapters and IoT cloud services. And there are a few use cases where Vorto can support there, and we will support there as much as we can, because the keyword is harmonizing of messages that are transferred using that IoT connector. That is one point, and the other point is, of course, device integration topic. And the protocol adapters, here are also use cases, for example, the lightweight M2M, the Lishan protocol, where maybe we will have a protocol adapter in the end, and Vorto can also generate code for this one. And we will have further demonstrators for the future. So it is absolutely possible that we also generate or create code generators for supporting, I don't know, Arduino based solutions or things for Raspberry Pi for demonstrating it. And we are also looking forward to further contributions, and we are happy to see where Vorto can be useful.
Okay, so the best way to get in touch with you guys is from the eclipse.org/Vorto webpage, then for which you included the link.
Of course,
people can reach out to you on the mailing list, etc., etc. So I don't see further questions. I wonder. I mean, if people have questions afterwards, feel free to use the comments on YouTube. That's we will be monitoring them and make sure that that Olaf is aware and gets a chance to answer them. One more last plug for the IoT Summit at EclipseCon. As Olaf mentioned a couple of times, if you want to learn more about what's happening in the open source community around IoT, so that is Eclipse projects like Vorto or Hono, of course, but we have also talks around LoRaWAN and the Things Network, Lightweight M2M, and stuff like that. So it's going to be a 2 days event on March 8th and 9th in Western Virginia, just next to Washington, D.C. airport. It's pretty nice facility, and I hope to see many of you from the virtual IoT meetup there. We are actually also partnering with the local IoT meetup in DC. So in case you cannot make it to the IoT Summit, well, I guess we will talk again in 2 weeks' time. The topic will be MQTT Spy. It's a UI for browsing and debugging your MQTT communication scenarios. MQTT Spy is in the process of joining the Eclipse PaaS project, and Camille from MQTT Spy is going to give us lots of demos and will show you how you can use this tool to actually quite advanced simulation scenarios and the like. So I'm looking forward to talking with you guys again in 2 weeks' time, and thank you again to Olaf. I really enjoyed the presentation. It's It's great to see all the progress that you guys have done. So feel free to reach out to Olaf should you have any questions. And thank you. Bye-bye.
Thanks, Benjamin.
Thanks a lot. Bye.